Box and Whisker graphs. No, this is not a lesson about Schrodinger's cat. And if you got that joke, welcome as the only other physics nerd to watch this video. Now, I hope that that joke was not the high point of this video. So what do box and whisker graphs do? Why are they useful? Why are they boring? Well, they aren't in answer to that last question. They're quite exciting. But again, I'm biased. So box and whisker graphs allow us to compare different groups of the population. How do the top 25% maybe compare to the middle 50%? Maybe how does that middle section compare to the lowest 25%? What does the top half maybe look like compared to the bottom half? All of those questions can be answered using a box and whisker graph. So let's see how they're made using an admittedly weird example. Let's take a look. So the first thing you have to know about box and whisker graphs is that they divide your data set into what's called quartiles. Now if you think about how that word sounds, it kind of sounds like quarters. And there are 4 quarters in a dollar. And so a quartile is dividing your group up into 4 equally sized subgroups, 25% of what you have. So in order to do that appropriately, you need to make sure that your data is in order. So if I were to divide it into 4 equally sized groups right now, some of the bigger bottles, some of the bigger values would be trapped down on the lower half, and that's not where they should end up. So the first step in creating a box and whisker plot is to organize your data from least to greatest. There you go. Our data is in order from small to big, and now we have to go ahead and start the splitting process. The very first split that you're going to make is called the median, or the middle. It divides your group down into an even 50% below and 50% above. One thing that's going to be important is how many elements are in your data set, how many pieces of information. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have an even amount, it's pretty easy to split into 2 equal size halves. All even numbers do that. But if I have an odd amount, there will be one thing left in the middle. Let me show you. Here, if I go ahead and split those 10 items up, I have 5 in the bottom half and 5 in the upper half. If I had this 11th object, it would get placed in the appropriate spot. And then I would have this middle object as my median. Now, numbers-wise, when I had 10 objects, to find the actual median value, you take these 2 innermost elements and you average them. So you add them and divide by 2. We'll go back to having just 10 items. So here are my 2 groups. Again, the median is whatever is averaged between those 2 bottles. Now, after we find this, we haven't found the quartiles. We've found 50% and 50%. Those are halves. So we're going to take the lower half and we're going to find the median again for it, because if I split a half in half, I get a quarter. So this is not too bad. I will have 2 values and then 2 values, and then it's this single value in the middle. So kind of like what we saw before when I had that 11th object. So here's my lowest 25%. Here's what we call the first quartile. Here's my second 25%, getting closer to the middle. And then I have to go ahead and take the top half and do the same process. So overall, you split it down the middle. You take the lower half and split it down the middle. You take the upper half and split it down the middle. And so my upper quartile is this bottle. We would say this is the third quartile. So I have my first quartile and I have my third quartile. The second quartile is that median value, which here doesn't exist as a water bottle, but it would exist as a number, the average between these 2. Now, in essence, that's one of the critical pieces of what box and whiskers do, is they divide it into 4 equally sized quartiles. 2 bottles, 2 bottles, 2 bottles, 2 bottles. And sometimes you're going to have a bottle or a value that's splitting it. Other times, it may be this invisible average that splits it. But there's one more important aspect of what box and whiskers do. Notice how these bottles are way larger than the bottles down here at the end? Well, they show that disparity. They show that difference. And in order to graphically see the spread of the data, if these are outliers further away or if it's all fairly condensed, you need to have what's called the 5-number summary. So the 5-number summary involves the first quartile, the second quartile, and the third quartile, but since you need 5 numbers to summarize, you're going to also take the smallest value and this largest value. So you will have where you start, first, second, third quartile, where you end. And those 5 numbers tell you where to graph your box and whisker plot. So once you put those values on a scale, on an axis, all you have to do is connect the first, second, and third quartiles to make the box part of the box and whisker graph. The whiskers are the lowest 25% to the minimum, and then the upper 25% to the maximum. Usually those are represented with just a thin line versus the big chunky box. That chunky box is where the middle 50% lie. That's like most of the normal people or the normal values. We would call the size of this box the interquartile range. From Q3 to Q1, what's that difference? How big or how wide is that box? Once you know those key pieces of information, it's relatively simple to make a box and whisker graph. And they're powerful visualizations for the shape or the spread of your data and being able to talk within subgroups of comparing different quartiles and where you land. Let me show you a quick example if we had 12 items, just so you can see the process again. And hopefully if you had any questions on the first time around, these will get answered here in a second. So to find the median, or split it between the lower and the upper 50%, since I have 12 items, I need to take the lower 6 and separate them. Okay, keeping in mind, everything should be in order, otherwise you don't really know what the median value would be. So here I have 6 below and then 6 above, the highest versus the lowest. Now, in order to find the first quartile, I need to take that lower group and split it in half. So 6 is easily split in half, 3, 3. Do the same thing with the top, so I'll scoot these over. So you can clearly see my quartiles are all the same amount. I have 3 bottles, 3 bottles, 3 bottles, 3 bottles. That's what splitting each half in half does. So when a situation like this happens, remember, the median or the second quartile is the average between those two. The first quartile is the average between those two values, and then the third quartile is the average between these two upper groups. In order to get your 5-number summary, which is critical for your box and whisker plot, you need to take this lowest value and this upper value, and you need to put those in this summary, this 5-number summary. You'll go ahead and you'll graph the lowest, Q1, Q2, Q3, and the highest value. You connect the innermost 3 to make the box, and then you extend your whiskers out to the minimum and maximum, and you're done. This will allow you to kind of see visually if you have outliers or things that are really far away, the whisker might extend for a long distance. Or maybe kind of in the middle, it's a wide distance, and then the whiskers are very short. So it's the width of your boxes or whiskers or those quartiles that shows you if it's stretched or skewed. Those are all vocab words that you should be familiar with from the first section. Now a warning. One thing that I have not really talked specifically about is what we technically should do with outliers. Outliers need to be represented in a special way for a box and whisker plot. They're actually not connected to the graph itself. They're represented by a singular dot out away from the rest of the data because they're so unusual. And there is a way to calculate that, but for this idea of how to make a box and whisker graph, I haven't described that yet. You'll need to go and watch my other video or talk to me about how you find outliers. There's a special way to qualify as being an outlier. So in general, this is the process of making a box and whisker graph, but you have to check for outliers first. Otherwise, your box and whisker visualization might not technically be correct because it's not showing outliers, things that are crazy far away or very unusual. So I hope this video helped. It helped me understand kind of how you have equal amounts of people in each quartile. And if you have any questions, just reach out. I'd be happy to help. Thanks, guys. We'll see you in the next video. Take care.